And another thing is, okay, with respect to assignment 2, the CIDC people, they are updating the website.
Could you try
Or
to
in fact,
also
the
split
website.
the time?
So it is currently down.
This is the one you
So what we are planning to do is
I know
PA is
what
going
happened.
to set up a new server and
If you
give
come
you
to
a
our
new
lab,
IP
I
address.
can show.
It will have the same functionality as the internet server. It is going to do that today. Right, today probably you will do that.
With
The server, new server.
yeah, I will.
Yeah. And then from tomorrow you can connect to the server. In the meantime, you can work on the rest of the app. We have your midterm on October 5th. October 5th, you have your midterm. So I will upload some sample midterm questions. We can discuss them. We will discuss them next class and also on the 3rd. Yeah, so next class we have an opportunity to discuss those questions and on the 3rd. So I will upload them probably today or now I can upload them. Basically the last midterm. Yeah, let me upload the midterm right now. So do you have any questions regarding assignments or the content that we are talking about? Anybody has any questions?
One for each.
This is the midterm for the spring semester. Let me show you. In the summer semester, we had a take-home midterm. So I told them to write a gesture recognition application. We cannot have take-home midterm for this big of a class. So we will have a class. And this is the midterm we had for spring. Now there is no guarantee that all the similar types of questions will be there. But we can try to solve it. So I will upload this. There were how many questions? 1, 2, 3, 4. 4 questions. No, 5. Yeah, 5 questions. There are 5 questions, and there are some extra credits. So this covers mobility models and many other topics. Like we have the fog server, cloud server, all those things. So these are mostly conceptual questions. So you won't find it in any book, or there are no fixed equations that you have to apply. You have to come up with your own equations, and you have to argue about that, whether that equation is right or wrong, or under what circumstances is right, what are the assumptions. So kind of open-ended questions. Although numerical, you see numbers there, but there is no right solution. So you have to kind of argue about it. Right? So yes, look at these and see whether these make sense, or whether you can do these, and we will discuss the solutions as well. So let me upload this. So now you can look at this practice exam. Any other questions? Okay, so let's, oh, you have a question?
Is the midterm still next Thursday?
Yes, please. Yeah, cheat sheet. Yeah, you can bring cheat sheet. It's a closed book, closed laptop, closed internet exam. But cheat sheet is only one cheat sheet, both sides. I don't care whether you type or write, whatever you can do. But don't throw the cheat sheets from here to there. That's not the problem. Okay, so in the agenda there are three things today. One is we'll talk about sensor programming because that's what you need for assignment 2. Then second is we'll talk about mobility models. And third is we'll talk about the paper today. Now the paper today is very similar to the paper which was last time. Right? This idea is kind of similar, but they have some other things that we need to discuss. So we'll discuss that in time. So we need to understand sensor programming. So how do we do sensor programming? So you know that we have discussed this before that Android has the smartphone operating system, not really Android. The smartphone operating system is midway between the desktop and the sensor operating system. So it has to support the sequential execution of a desktop operating system. Also it has to support event-driven execution of a sensor. Right? So it's a medley of the two things. So you have a Linux OS that interacts with the hardware, but then the Android framework on top of the Linux OS also gives you provisions to do listening to a sensor. So listening to a sensor means you are trying to understand events coming out from a sensor. So how do you do that? So basically this is the method that you use. You instantiate a class or instantiate a background thread, which is essentially a listener. And this background thread can be a service, and this service can extend a sensor listener class. So that is exactly how I have implemented in this code. This code is also uploaded. It's called accelerometer tutorial. So what we have here is the same things. There is a main activity, then on create. So whenever there is on create, you go there first. Right? So in here I have a button, and when you click the button, it starts a new service. Right? It starts a new service, and this service is using start service. Right? So that means this is not bound. This service is not bound. So once you start this service, it keeps on. It is always on. It never stops. Now here you see that there is some new things, but there are some new things here. Bundle that put string, and then start service, sales service that put extras. Now we understand that there is, once a thread is created, there is only one way to communicate between the main thread and the thread that is created. That is through inter-process communication, through sockets. But there is another way to pass some information from one thread to the created thread, from the main thread to the thread that is created. So that is this way. So what you can do is, you know that whenever you create a service or any other thread, you need intent, right? So in that intent, what you can do is you can pass certain messages through the intent. So how to do that? So there is a class called a bundle, and you declare an object B of that bundle, and in that bundle you can club different types of variables. So it's like a structure. Bundle is like a similar concept to a structure in C. Right? You can combine many different types of variables. So here what I have done is I have built an application. That accelerometer tutorial is an application which detects fall. So if a person fell, or if the phone fell from the hand, it will detect that there is a fall, and it will notify to a caregiver. So this phone number is the phone number of a caregiver. So what we do is you type in the phone number and you click start service button, and then this button gets clicked. So this phone number is bundled up in this bundle B, and with the intent, it's passed on to the service. So how do you do that? You do b.put string, you put the phone number, and you have to give a key. The key is the phone, the text, that is the key. So using the key, you can extract the value. That is how the bundle works. So then what you do is, in the intent start send service, by using that dot put extra, that function, you can infuse the intent with some of the parameters from the UI thread. Right? So you can pass some information from the main UI thread to this service. Then you just do the normal start service, start send service, and it starts working. Now, how do we write that start send service? So this is a different type of service, because now it is listening to the sensor. So it has to have something more than just a service. So let's look at that. Oh, this thread. So you see that is the same thing, sensor handler class, and it extends the base class service. But then there is something extra after that. Because this service has to now listen to the sensor. So it has to implement a sensor event listener. So that is the new thing that Android adds on top of Linux to make it a smartphone operating system. Right? Linux doesn't have this listening type of operation. What Linux has is just a interrupt-driven operation. Right? So it doesn't really listen, but you can interrupt the sequential operation of the CPU. But here, implement a specific listener for a sensor. Right? So how do you do that? So you have sensor handler class, it extends the base class service, and that base class also implements sensor event listener. So now, with the moment you implement sensor event listener, there are 2 or 3, I think, default functions. What are the default functions? On sensor changed is one default function. Then on accuracy change is another default function, and then these are the default functions for sensor event listener. And then there are those regular default functions on create, on start command for the service. Right? So these are not new to us, this we know, but these we don't know, on accuracy change and on sensor change. So what is on accuracy change? Let's look at on accuracy change. So through this function, what you can do is you can change the parameters of the sensor. You can say change the sampling frequency, or you can change, or you can delay the start of the sensor. Those kind of operations you can do using on accuracy change. Or you can also specify the resolution if the sensor allows you to do that. Then what happens on sensor change? On sensor change, what happens is that this sensor listener is doing what? It's regularly sampling the sensor to see if there is new data. If there is new data, then this on sensor change function gets called. So if we have a sampling rate of 10 Hz, so regardless whether something happened or not, every 100 milliseconds you will have one new data. Right? Regardless of whether anything new happened in the environment or not. If you specify 10 Hz as sampling rate, then that means every 100 milliseconds you will get a new sample. It might be the same as the old one, but still it's considered as new. So every 100 milliseconds, this function gets called on sensor change. Now the thing is, you don't know which sensor you are listening to. You have implemented a sensor event listener, but which sensor are you listening to? There are so many sensors. So how do we specify that? So in order to do that, you need to declare certain things. You need to first declare a sensor manager, and you have to declare another thing called a sensor. So sensor manager class and the sensor class. What is the sensor manager class? It's a generic class for any type of sensor. What does it do? It's using the sensor manager class, you can bind a listener to a particular sensor, or you can start and stop a sensor, you can change the sampling frequency of a sensor, and so on. What is the function of the sensor class? Using the sensor class, you can now make sense of the data that is coming out from the sensor. Okay? You can know the format of the data, you can know the actual values that the sensors are sending you. Right? So that's why you need two classes, two separate classes. One is to manage the sensor, start, stop, change sampling frequency, bind a listener, or and the other is to make sense of the data, which is this sense. So what you do, you declare these two, and then these are the areas where you store the data. And I chose to store 128 sample points, and you can change this, no problem. Then what you do is, before even plotting this on sensor chain, you have to bind them. Where is the binding code? Yes, on create. On create, what we do is we first declare this sensor manager. You first declare this sensor manager and you say that okay, get system service is the sensor service that we are trying to access, and then we are also specifying what type of sensor it is, which sensor do we want to sense. So we are specifying that this is the accelerometer sensor that we want to sense, and by giving sensor delay normal, what we are saying is that we are basically specifying the sampling frequency. So we are just using the default. So here you can specify whatever you want. And you have to specify time intervals. So if you say 10 means 10 milliseconds, then that means 100 hertz. If you say 100, then that means 10 hertz, right? Not 10 samples per second. And then you register the listener. So using that register listener, what you did was, so using the first line you configured the service. Using the second line you told it exactly what sensor I am going to listen to. And using the third line you started the listener. Right? So that is the way to bind a sensor manager to a very specific type of sensor, which is the accelerometer in this case. Then what happens? So whenever a new data comes in, now since you have already bound the listener to that particular accelerometer sensor, so whenever new data comes in, it will this function will get triggered. Which one is this one? Yeah, the send on sensor change function gets triggered. Now you have to make sense of the data, right? Yes.
If you found the sensor, the listener to the accelerometer sensor, why are we checking for the type?
Where am I checking?
The if condition.
No, okay. So the thing is, in that sensor, my sensor, that sensor can listen to. So when we say sensor type accelerometer, it's actually not only accelerometer. It talks to accelerometer, gyroscope, and orientation, all three, right? So that is kind of misleading. The type accelerometer when we wrote there, that is kind of misleading because it's not only accelerometer, it also gives you orientation, gyroscope. So here you have to check that I want just accelerometer. So by accelerometer they mean IMU sensors, all three.
So, but then that means this type also include those two sensors.
Yes, so that's why. No, this one, the sensor, my sensor, has all three. Now that's why you have to say that okay, this get type. When you do get type, you have to say that okay, then I want the accelerometer sensor, not all three. Now that is one purpose. But other purpose is that by specifying the type of accelerometer, you are also specifying the data type. Because accelerometer will have a different type of data than maybe EMG sensors. Right? EMG sensors has 8 axes, 8 pods. whereas accelerometer has 3. So you are specifying how to read the data. So you come here, you do get type sensor dot type accelerometer, and then using that sensor event, sensor event, there's some problem. Where did I declare the sensor event? Oh no, okay, so that gets passed to this function. Okay. Yeah, so one of the arguments of the on-sensor change is sensor event, and that has all the values. Right? So then what you do is you take the values from sensor event and you are storing it into the arrays. Now once you have 128 values, what I have done, and you may choose to do something else, what I have done is I have unregistered the listener. Why? Because if you don't unregister the listener, you will keep on getting accelerometer values and it will overflow your buffer. So you might choose to do this, or you might choose to have another buffer such that whenever you are doing this this computation, the accelerometer values goes to a different buffer. You can choose to do that also. It's up to you what algorithm you use. But yeah, regardless of that, yeah, you have to. I chose to unregister the listener. You might choose to do something else. And then I called some function. Now this is a very poor way to implement. Ideally, what you should do is you should call another background service and pass the function there. Right? Because this call for recognition is going to take a long time. So if it takes long time, then during that time you have unregistered the listener, which means that you are losing out on data. So I would say don't follow this type of implementation. Instead, what you do is you create another thread, and in that thread you call that fall recognition. Right? So then in the fall recognition, it can be either fall recognition or gesture recognition. I don't care. You have to write that function. So this I have written a very simple fall recognition function. I also have a gesture recognition function which recognizes the wave gesture. Like if you wave, it will recognize it. So you can also call the gesture recognition function as well. So once it is done, then it gives you a result, and after that you again register the listener. If you again register the listener like this, it will restart the accelerometer. So that is just the sensor portion of assignment 2. So you can use this code, but just modify that one for recognition to have a new thread instead of using it in the same service thread. Right, so this is what I had planned for the implementation part of the course. Do you have any questions? How many of you are already done with interfacing with the sensor and collecting data? Not the Wi-Fi part, but just interfacing the sensor and collecting data. Nobody? So this is useful. You can now use this code. What I will do is I will also explain connecting to a web server through Wi-Fi. We will also discuss that code. So basically the entire assignment is there also. Yes. Because it will take time. It will take time to execute that function, and while it is taking time, we have already unregistered the listener, so we are losing out on accelerometer data. So let's say fall recognition took 30 minutes, and within that 30 minutes, if you have another fall, then you will miss it. So what you do is you have another thread. So you unregister listener, yes, but then instead of calling the fall recognition function, you instantiate the thread and immediately register the listener again. So starting a thread takes very small time. Right? You just do a post, you put it into the queue, and you're done. So that's why you just start the thread and then register the listener again. So you lose data, but not as much. If you don't unregister, then the sound sensor change function will get called over and over again, and you lose track of how many call for recognitions you called, how many times you called that. Any other questions you have? So download the code and see if it works. It should work. Now let's go to our discussion on mobility models. Right. So last class we were stuck here. Probability theory we did, and we also used a very interesting story, at least interesting to me. Don't know about you. So let's talk about Markov chains. So in the slide, as I have mentioned before, there are a lot of equations. I don't like to use equations because it gets very confusing. So big equations are there. We won't talk about those. We'll talk about the intuition behind Markov chain. So we used an example last time, but Markov chain you can use for many different examples. For example, you might have faced this problem that you are going through a narrow road, maybe, right? And if you go straight, and another person is coming from the other end, and he also comes straight, then you collide. So somebody has to move. So what ends up happening is that you take a right step, the person also takes a right step. You take a left step, that person also takes a left step, and you are stuck, deadlocked. Right? So what you can do is, if you are that nerdy, then you go and develop a Markov chain model of that person, and you predict that when is this person is going to take a right step next, then I'll take a left step. And I have a guarantee, probabilistic guarantee, that after doing this 3 times, I will pass. You can choose to do that. So basically, what is Markov chain? What is it used for? It is used for characterizing or developing probabilistic models of anything. So, how do we develop this person's? Let's say we want to find out that whether this person is trying to take a right or left step. How do we develop this model? So here, first of all, what we will have to do is we will have to try to understand what are the outcomes. What outcomes are we interested in? So we are only interested in the outcome that right or left step. In this case, just assume that. So if that is the case, then corresponding to the number of outcomes, you have number of states in the Markov chain. So how you can model this? What you can do is you can observe that person is coming from far off. You can observe that okay, this person first took a right step, then he took a left, then right, right, left, right, and you do this. You observe the person over 200 steps, right? You observe. Now you know that okay, there are only 2 possibilities. The person can take a right step, or the person can take a left step, because you didn't see any other possibilities. Right? Now what you do is you make an assumption. You make an assumption that this person doesn't have a very well-formed idea of where he wants to go. Right? Doesn't know that where he wants to go. He just goes wherever. So this means that the person's history of taking steps does not matter. The only thing that matters is that what step this person took right now. Now that is true for many examples, but not true for many others. So some examples that is true is the example that we saw last class, that the person is drunk, so he doesn't have any goal, so wherever he just takes whatever steps he wants. The second thing is somebody is dancing somewhere and doesn't really know how to dance, so you can use a Markov chain and dance, right? Find out the next step. So these can be applied in many other examples as well, Markov property. But we will talk about that property a little bit later. So what is the assumption? The assumption is that what step I take next doesn't depend on my history of whatever steps I have taken before. The only thing that it depends on is the current step. So I know that I took right now, the right step now. What is the probability that I'll take the left step next? So my probability that I take the left step next only depends upon what step I took now. Right? So if that is the case, if you make that assumption, simplifying assumption, then what happens? What you can do, you can look at the data and you can say that okay, this person was right step now and he took a left step next. Right? So you count that this is 1. Right? Then you again go to the place where the person took the right step. So you say that if the person took a right step now, then he took another right step. So this become 1. You are counting. Then you come to this. This is another right step that the person took. So the person took the right step now, then he took the left step. So this count became 2. Right? So and then this is left. This is right. Right. So again you go back here, go to here because this is another right step. And you say right step now, left step again. This became 3. Then you come here, right step, this became 2. So you keep on counting. You keep on counting and then you count the total number of cases where the person took the right step. And so there's 1, 2, 3, 4, 5, 6. There are 6 cases where the person had taken right step. So then what you do is you say cases where person was in right, the current step was right, and then he took left. So these are cases when the person took a right step because its current state, and then took a left. Right? And then you say CR, which are cases when the person took a right step. Then simply what you can do is you can say that the probability that you take a left step next, given that the current step is right. Right? This is the probability that you take so given that your current step was right, what is the probability that you take the next step as left? So that you can simply calculate as CR LL by CR. Okay? You are developing the Markov model. So that is an assumption that you make. The assumption is that it doesn't depend on the history. There is no specific goal for that person. No patterns. The only thing that matters is what step you took now. So in that case, what you can how you can represent in a graphical way is that you can have an arrow. You can have an arrow from R to L, right? And you can label this arrow by this probability of L given R, right? So L given R means where the arrow ends, that comes here, and where the arrow starts, it comes here. Right? Yes. So, what? Oh, so numbers on top is I'm starting from here. So let's say this is my start state. Start state. So this also you denote in the Markov chain by an arrow like this, like start state. So now what you do is, this is a start state, so you know that you are in right. So if you go once from right to left, you calculate it as 1. That's the 1 time. You increment CRL by 1. Then this current step became L, so this is not a part of this, because CRL means that your current step is right. So you go to a point where your current step is right. Now then you say that this is from R to R, so this does not affect CRL. What affects is R to L, so you go to this point which is R to L. So you know that you increment CRL again by 1. So CRL becomes 2. Right? Then you go to another point where you have right to left. So here you went here. So right to left you have another instance. So you increment CRL again. CRL becomes 3. And you go and so on. Right?
Here we are counting the number of right to the state as 6. So there must be some existent or some state after.
Yeah, it will continue. It will continue.
Otherwise, it won't matter.
Yes. Yeah, it will continue. So Markov chain assumes that you have some history. From those history you get the probability matrix. But once you get the probability matrix, then in the future you don't need the history. In the future everything depends upon the current state.
Professor,
Yes.
so why in step 5 and 6 does it go down from 3 to 2?
No, that is not CRL. That is CRR.
Yeah, but then there's 2 above the arrow.
Wait. So this is CRL. This is CRL. This is CRL. This is CRR.
Different. Okay.
This is CRR.
Okay.
Right? Yeah.
Is CR different from CRR?
CR is different from CRR. So why is CR different from CRR? So if given this definition, this definition of CRL, can I define what will be CRR? Yes. What is CRR? So just replace right by that. So cases when the person took a right step and then took another right, that is CRR.
Yeah.
Now what is CR? CR is cases when the person took a right step. The moment the person takes a right step, doesn't matter what he does in the future. Just right step you count those. So that is the difference between CR and CRR. Any other questions? Okay. Yes,
So in the denominator, don't you think that should be C and instead of CR?
C?
And instead of CR?
No, CR. Why? Because it matters on the current state. The probability only considers the current state, not the future state. If it was CR, it would have been the future state. So that is the Markov property. That I don't care about the history, I don't care about the future, I only care about the current state. This is very cool, right? I only live in the present state. People say, right? Don't worry about future, don't worry about past. There are many sayings like that. So you should live life like a Markov chain. Yes.
So with that probability done, so that the
So the count, so this is, count the number of times where you, the current step that you took just now is right step, and then the next step that you took is left. Over the number of times you took the right step. Okay. Any other questions? Any other clarification? Yeah.
Taking step, you mean moving the
Actual step or anything, it can be anything, and you don't have to take a step. You just think about it, that is also. So the notion of state is, you cannot really visualize the notion of state, but you can consider that, okay, the person takes a right step. That is also fine. And now taking right step doesn't just mean that you just took this as right step. It can also mean that you took this, so you move forward. So what is this notion of state? That is not really, it's not tangible, the notion of a state. It can mean many different things. Depends on how you define. Yes, you have some question? You're explaining? Good. Just don't do it during an exam.
How big does a data set have to be till you build a probability matrix?
Pardon?
How big does a data set have to be?
That's a good question. We'll come to that. We'll come to that and we'll figure out exactly how big a data set should be. Right? We will have to explain. So let's say you have enough data set. Now what is enough we don't know. Let's say you have enough data set. Then you can find these probabilities, right? So now similarly you found these. You can similarly find CRR by CR, right? So this is what CRL by CR. Then you can have this probability that the next step was R given that the current step was R. So this is what CRR by CR. This you can do. Now similarly you can also make out these things. So CLL by CL, which is probability that you took the next step left given that your current step was left, and you can also have this PR given L, which is the probability that your next step was right given that the current step was left, so which is CLR by CL. Right? Now this is just a representation, doesn't mean anything. We just drew some pictures. But the real question comes later, that how do you use it, right? How do you use it to build a mobility model? That's our goal. And what is the goal of a mobility model? You have to predict something. You have to say something about the motion. So how will we say that? We will have to understand that. So in order to understand that, you have to first understand certain basic properties of this diagram. So what is this diagram saying? What are the basic properties that you can think of? So if you see, if you just take the right node, right? You just take the right node and you find out the arrows going out of the right node. And if you sum them up, the probabilities, what should it be? 1. Why should it be 1? Because from once you have taken the right step, the current step is right step, what are the possibilities? Either you can take another right or left. There are no other possibilities. So only 2 arrows coming out. So these 2 arrows, summation of probabilities should be 1. Note that it shouldn't be the case that the arrows coming into you, summation should be 1. No, that's wrong. Because why? Because the arrows coming into you means you are the future state. You are not the current state. And Markov chain doesn't say anything about the future state. Yes.
Here, it won't come.
Why?
Because we have to define one more state.
Yes, that's the length of the day. Yes, you have to define one more state. Exactly. Yeah. But a model is it's a Markov model if the summation is 1. If not, then it's not a Markov model. So you have to define new state, maybe adjust something, make one more as an observation or something like that. Pardon? Yeah, so intuitively what happens is that Markov chain says that okay, what next step I'm taking depends on the current step. So let's say the current step is right. Right? Now what are the possible next steps I can take? Right or left? No other possibilities. So the probability that I take a right step given that my current step is right, plus the probability that I take a left step given that the current step is right, should be 1, because there are no other alternatives. Probability, if it's not 1, then that means there is some other alternative. So it has to be 1 if there are no other alternatives. So now let's take an example. No, let's take the example later. So now, what can you say? What can you say about this figure? What does this figure say? How do you use it? So one thing you can immediately say that if the current step is right, you can immediately say that what is the probability of the next step? Right? That you have from the figure, you know, PL given R. The probability that the next step is right, left is that I know from the figure. Right? That is easy to say. Now, can you say what is the probability that my second step will be left? Can you say that? From this figure, instead of saying that what will be my next step, what is the probability that my next step will be left, I am asking you the question, what is the probability that my next step, the second step, will be left, given that my current step is right? Can you say anything about it? How can you say? What will it be? How? So given that you are right, yes, yeah, you follow? You follow the path. So now remember, you have to take 2 steps, not just 1 step, right? So what are the different possibilities that you take 2 steps? Left to left, right? There are 2 possibilities here. So one possibility is you first take a right step and then you take a left step. So that means that you took a left step, your second step was left. Then another possibility is you take a left step, first one, and then again you take a left step. So again that means that the second step that you took was left. Doesn't matter what happened in between, right? So if we try to mathematically express that, then what will happen? So this is the probability that my second step is left, given that my current step is right. How do I write it? So it's what he's saying is that okay, there are 2 possibilities. First you take first step right. So what is the probability that I take first step right? Right. Then what is the probability that I take a left step from that right step? And then there is another possibility. There is another possibility that I take the left step first, so PR given L, and then I take again the left step, right? PL given L. Then you end up in the right step, but I want the left step. Do you understand why? Which one? Sorry, yeah, PL given R, yes. Good. And that means you're paying attention. Should be this. Now this, there is an easy way of computing this. Probably you know. So what you can do is, this figure you can represent mathematically using a matrix. It's called a transition matrix. So what is this transition matrix? So let's say the AT is a transition matrix. So let us say ATR. So this transition matrix, you can write it as probability of L given R, probability of R given R. Yes. Actually, like this. R given R, then L given R. Right? And then you say probability that R given L and probability L given L. You can write it like this. This is the transition matrix. Now if you do a square of the transition matrix, square means A transition matrix multiplied by A. This. What will you get? If you multiply, so if you multiply, what will you get? You multiply this by this, right? So P R R square plus P R given L, L given R. Is it true? We have to do the multiplication. Yeah, it's correct, I think. Now I don't have space.
PRR.
Can you do the multiplication? Let me know that. I will answer. That is wrong. So what will this row multiplied by this column, right? The first element is this row multiplied by this column. So that was right. P R given R squared plus P L given R multiplied by P R given L, right? Then this one is this row multiplied by this column. So that is P R given R multiplied by PL given R plus what is it? This multiplied by this. PL given R multiplied by PL given L, right? Then the next one is this multiplied by this. So P R given R multiplied by P R given L plus P R given L multiplied by P L given L, right? And this one is this multiplied by this. So P R L given R. Wait a minute. Well, this comes out to this. It got messy, but I think it's right. Right? So what is it? You did what is that? Transition matrix. Yeah, transition matrix squared. So what do you find? What is that? PR given R multiplied by PL given R and PL given R multiplied by PL given L. What is it? What did we found out here? Exactly this one, right? So this is the probability that the second step is left given the current step is right. That is this. You'll find out that this is the probability that the second step is right given that the current step is right. This one is the second step is right given that the current step is left. And this one is the second step is left given that the current step is left. Right? You just square the transition matrix. So if you say that what is the probability that the nth step is right given that the current step is right, how will you find out? Just do a to the power n. Just do a to the power n, you will find it out. So let's take an example here. So is anybody has any questions about this one? So let's take an example. Now let's say my transition matrix is this. I have a transition matrix that looks like this. So 0.4, 0.6, 0.3, 0.7. Is this a good enough transition matrix? Does it set, is this a Markov chain first of all? Why? Sum it up, sum the rows, it will be 1. Now what is my a squared? How much is it? Can anybody open up a calculator and try to find out? Right. So what will you do? Let me find out here. What happened? What? It can't open calculator.
0.34, 0.66.
Okay, give it to me. Yeah, 0.34.
0.66.
This one is 0.66. 0.66. 0.33. 0.60. 0.67. Okay. What is a cube? Yeah, an easy way to do matrix square cube. 0.334. 666. That's a very bad number. Then 0.333. 667. Can you do 4? Actually do 10. What?
I can do step.
So do 4, 5, 6, 7. Do 4. Zero point 3334. One more 3. What do you see here? What are you seeing here? It's converging to a value, it's not changing anymore. So a to the power 10 will be same as a to the power 4. This is a mathematical property. But what does it mean in practice? What do we do with this property? Do you have any idea what do we do with this property? You come back to the question that she raised. How do we know that we have enough data? How do we know that? So what is that 4? 1, 2, 3, 4, what is that? Steps, right? So this directly tells us how many steps do you need to observe. How many steps do you need to observe before you can say that this Markov model that I have built is a true representation of the person? Or not only true representation of the mobility, but not really true representation of the mobility, or rather what you can say is that if I have more data, the Markov chain doesn't get more accurate. So if I have less data, then I might observe more. If I can observe more, my Markov chain will get more accurate. But after this point, if I observe more, it's no benefit. There's no benefit in observing more. Right? So if you have observed the person 10 times and you build a Markov model based on 10 observations, then what you should do is you take that Markov model, you multiply and you predict what is happening and keep on checking whether is it converging. If it's not converging, take some more observations. Right? So you take observations until your Markov, the transition matrix, multiplication of transition matrix converges to a value. So if it is 100, it is 50, is 70. That many observations you need before you can say whether this Markov chain has reached its limit. There is no guarantee that this will be accurate. There is no guarantee. But you don't need more observations to make it more accurate, because this is the limit. So this mathematical property has a physical significance. Now, why I teach Markov chain in mobile computing class is that this gives you a very great intuition about what mathematics can do in practice. It's a very simple structure. Markov chain is a very simple structure, but it has such powerful predictive capabilities. So the next thing that we will talk about is can you tell me an average time? Right? Let's say I give you that you took a right step right now. Can you tell me an average time after which I will see the person taking a left step? You can ask this kind of questions. You can ask the question that, okay, what is the average time that the person spends in a particular step, or particular state, which means, it's hard to imagine in the context of left and right steps, but if these states meant something else, say battery states, if these states meant battery states, then you could ask the question, okay, how long will I, on an average, how long does that person's smartphone spend under 25% battery? Right. How long does it spend under 25%? So based on that, you can take many different decisions. So those kind of questions you can ask. That is the power of Markov chain. Right. So now we will ask the question that, okay, how many steps do we need? Or no, we'll ask the question that, given a right step, how long does it take us to see another left step or to see another right step on an average? But that question will answer next class. Now today we have to talk about the paper. Right? So let's talk about the paper. Now, given that we had already discussed a paper which is similar topic, I was not really impressed with the paper. But that should not deduct any points from the rigorous, right? Because we don't have any points for paper selection. But this paper, I don't know what is the novelty. Who selected the paper? Don't hide. Or maybe they didn't come at all. Oh, you selected. Okay. So you have read it, I am assuming. You selected? Oh, you have read it. Okay.
We are group 7 and
Oh,
8.
okay.
Yeah.
So can you tell me the novelty?
Well, they're trying to differentiate between sensitive data and not sensitive data and the camera. And when your app is using different apps using camera, they're trying to select regions that are not leaking any sensitive data.
So how is it different from the IP?
Which one, the last one?
The last one? Because they are also doing sensitive in the sense that bystander, that they are considering that is sensitive, but they are doing it in an automatic way. Here you have to specify. Right? So that was my concern.
They're showing that it can be used in real time.
So that was also real time. So that is the concern that I had with this paper. But let's see. This is still interesting to me. Let's.
Well, they had different approaches, but we can.
There are different approaches, surely. So let's talk about this paper. This is what you mark is what I see. So they have combined two approaches. So they do it in 2D as well as 3D, and that is one thing that I see as novel, because the IPIC one was just in 2D, right? Two-dimensional pictures. You can say that you can automatically recognize face, and you can say that they don't want to. But this one can do it in 2D as well as 3D. So now the thing is, what they are saying is that when you take a picture, they are not really restricting their application to taking pictures. So yes, now I understand novelty. Okay. So this is really novel. Okay. So what is the novelty here? IPIC only did it on image captures, camera. They show 3 different scenarios. So if you go to here, this figure 1, they show 3 different scenarios, and these scenarios are interesting. Let's read on. So Alice is attending a client presentation in Shanghai. So Alice and Bob are very famous people. We will talk about them when we are talking about security, right? So this paper is also related to security. We will come back to some of these papers when we talk about security problems. Right? We'll come back to this. So that is one of the reasons that I have this research component, so that we know exactly what is going on in the current state of the art. So yeah, let's read on. Alice is attending a client presentation in Shanghai. Since some of the text is in Mandarin, Alice would like to verify that she translated the text correctly using a third-party translation app on her mobile device. So this is a translation app. What does it do? The app captures slides from the presentation, runs optical character recognition on each frame, and displays the translated text on her mobile device. However, the slides also contain sensitive corporate secrets. How do you differentiate between sensitive corporate secrets that is written in text and is embedded in other forms of text, especially when this text is already translated? That is a challenge. So both Alice and the client are uncomfortable that her translation app may forward the secret information to untrusted servers for processing. That is a real threat, and that is a totally different type of application than IP. Right? So they are not only restricting them to image capture, but they are they are opening up the space of applications where this can be used. So that is why this is novel. The technique itself is not novel. What is the technique that they are saying? Okay, if you have some sensitive information, mark it. Right? You mark it, say, this is sensitive, and they will blur it. So the application as such of doing the blurring or finding out the context sensitive information is not novel, but the domains where they are using it is very novel, right? So let's say another example. Bob is video chatting on his laptop with collaborators. He would like to use his whiteboard to work out a problem, and hence would like his collaborators to see it. However, he has a confidential product roadmap on his whiteboard, and that his collaborators should not see. Or if he is in his own room, something else is there, right, which the other people should not see. He also has a prototype model of a newly designed drone and a bottle of medication on his desk. Bob would like to show the prototype to his collaborators, but would be upset if his collaborators saw his medication. Right. Now this application is kind of like a bystander application. Right. So here what is it? It is like you are taking instead of image you are taking video. So that is another different domain that they are going into. IP was only image, but this is also considered video. So video is very different from image, and you can consider that video is collection of images, yes, but then there is this factor of time, right? So if you say that okay, if you encircle that one object, I don't want to show it, then if you want to blur it or obfuscate that object in subsequent frames, then you cannot ask the user to go frame by frame and mark this object. Right? So you have to track the object. So that is another big challenge that this paper is solving. Oh no, I don't know whether this is solving or not. Is this solving? Okay. So this paper is solving that. So that is another big challenge. So that is another novelty of this paper. Now then another video chat scenario is there which says that okay, Kathy relies on Kathy. We won't talk about Kathy later. We'll talk about Trudy. Trudy is another villain, very famous villain. So Kathy relies on an augmented reality app on her mobile device to superimpose indicators over her keyboard to help her input a complex password. But that is a very interesting application. So what it is, often people do this in laptops or desktops. Used to do this before. So they will forget their password. So to remember, what will they do is that they will mark the keys that you need to press to remember your password. They used to do it in laptops and so on, but Kathy is choosing to do it in mobile device. Very dangerous thing to do. But her choice. While she is comfortable allowing the password app to view her keyboard, she does not want the app to capture her computer screen or anything else on her desk. So this is another different type of application. This is not iPic again. Right? So you are not taking the picture. This is an app that is trying to access. So when a person is taking picture, you have more control. Right? You can set rules. But when an external app is taking picture, you cannot set rules. And even if you set rules, there is no guarantee that the app will follow the rules. Right? So these scenarios give them extract or show the novelty of this word. Right? But then the rest of it, the technique is not really novel. So what they do is here, so if you want you can select objects and you can mark them, and where this is private, this is public, and then what they will do is based on the markings they will alter the image. That is the rest of the paper. Now they talk about many different technology, for example private eye and all those are competing technologies. And so this paper is also useful to talk about or to understand those kind of competing technologies. They have evaluated on two different applications, private eye and wave off.
These are actually their system that sits between the camera and the apps.
Yes,
And just
the private eye and the wave off, right? So using those two, private eye is for 2D, right? And wave off is for 3D. So using those private eye and wave off, they are implementing those strategies to obfuscate the image, or somebody can figure out like which object to obfuscate. Now user study is one of the important things in this type of papers. So what you have to do is you have to give these applications to users and ask them questions, asking them how do you like it or not and so on. So that is a very boring part of the research. Like you have to give users and maybe ask them questions so that they are forced to like your product. Right? They ask a lot of questions. Okay, I don't want. So it is good. So that user study, right now many conferences want you to have a user study. For example, IUI, those conferences have to have user study because everything is user experience related. But doing that study is very cumbersome and very boring. I have done it 2-3 times. I don't like it at all. So this is my comment on this paper. I didn't get a chance to go through the examples or no, the experiments because time is up. But we'll come back to these two papers, iPic and this one, when we are talking about security. We'll come back to this. So yeah, write the reviews and scribe.